In one of my recent videos about capacitors, I taught you about reactance and how capacitors behave in AC circuits, and I gave you the proper technical mathematical explanation. Here's how my brain works, in case anyone has a similar brain to me. I know fundamentally how a capacitor works in an AC circuit. It makes sense in my head. These two relationships. With time, the current decreases, and with time, the voltage increases. Now, in an AC circuit, we can have high frequencies or low frequencies. And the way I see it is, if we have a high frequency wave coming in, you're not giving enough time for the capacitor to actually charge and discharge as normal. It stays within the shorter time range. And so the current is always going to be high, i.e. it has less resistance. The opposite is true with low frequency. If you have a very low frequency wave coming in, you're giving a lot of time for the capacitor to charge and discharge. It hangs around on the lower edge here in the longer time range, and so the current is lower. If the current is lower, that means that the reactance is higher. This explains as to why the reactance, i.e. the resistance of the capacitor, is inversely proportional to the frequency. Not only that, but in future studies when studying passive filters, this concept is really embedded in my brain. I can always work back to how any passive filter works based on this idea of the frequency being high or low and how the current behaves. If you found that too confusing and prefer the mathematical way, that's okay. I'm just sharing how my brain works in case anyone else can also catch my same wavelength. Happy capaciting!